Right, this is lecture 11 on analysis, and it's on monotonic sequences. He proved a lot of stuff from the hierarchy of limits last lecture, so if you want the proofs then I can give you the notes, or I've got the recordings as well if you want an email. Right, first off, definitions as usual. We have, these are common sense again. All this proof by common sense. So we have a function is increasing if the next value in the series is greater than or equal to the previous. It's known as strictly increasing if the next value is greater than the previous, so this one we've got greater than or equal to. It's decreasing if the next one is less than or equal to, and strictly decreasing if the next one is less than the previous. And we have monotone and monotonic functions are either increasing or decreasing. So if it's either one of them, then it's monotonic. Right, an example. I've kind of just put everything on there because it kind of follows itself quite easily. We have our example here. An is 5/2, and an plus 1 is a fifth, an squared plus 6. And we're trying to, they made the claim that an is greater than 2 and less than 3. So we want to see if it's right first. So if it is true, then clearly if we square all parts, then this is true. And then if we add the 6, so we've got this part, then this is true. And as we've got the fifth here, if we do apply the fifth to these, then we get 2 is less than an squared plus 6 is less than 6. Oh, and this is over a 5 as well. So we've just proved that this is between 2 and 3 as well. So that's true. Works fine. And now they made the second claim that it's monotonic or monotone. And to prove this, we want to see if it increases or decreases. So what we've got here, we've got the previous value minus, the new value minus the previous value. And if it's either decreasing or increasing, then we know that it's monotonic. If it's 0, then it doesn't do anything and it's not monotonic. So we have our equation here and minus that, so that's just following from this. What we've done, we've moved this inside. So we've got the fifth, so we need to put times by 5, so we have minus 5an. Then you can factorise it, so we have a fifth an minus 2 times an minus 3. And what we already know up here that an is between 2 and 3. So if an is between 2 and 3, then we subtract 2, then this is going to be positive. And if we subtract 3, this is going to be negative. So we have a fifth times a positive times a negative, which gives us a negative. And so we know that this is decreasing. This is a decreasing function, and so that it is monotonic because it's one of the things. So it is decreasing.